Okay, listen up here, guys. So this activity here, guys, we're working on just as a review of kind of Newton's third law. Okay, um, so the when you're in Google Classroom, you'll need both of these documents. Okay, this is the one where you'll actually type in your answers. Okay, the Google Doc is the one where you type in your answers. The PDF is the one that actually has the reading part of it. Okay, so the scenario is this: there's people out there, and now Nike's made that stupid running commercial where, you know, if everyone runs the same direction, they can make the world turn the other way, which is stupid, but they did it, and people believe it because people are stupid. But anyway, so there's this idea that if you got everybody into the same place at the same time and they all did the same thing, you could somehow affect how the Earth moves. Okay, so what we want to look at is kind of the scientific validity of that, but also the, let's say, more practical issues with getting everybody into the same place to jump, because that's going to create some major problems. All right, so what you have here is just a little document that I want you to kind of have a read over. All right, and then we'll talk about it quickly, and then we'll have you guys work on the questions. I'll give you a couple of the numbers that you'll need to work on the questions. Okay, we'll get those done, just submit it, and we're done. It's just kind of a small in-class activity. Okay, some easy marks for you. Okay, and a good review of Newton's third law. All right, so what I want you to do right now is just read the PDF file, okay, that's in Google Classroom. That's this document here. Okay, give it a read through, and then I'll kind of talk about it with you, and then I'll have you work on the questions and give you a couple numbers for that. So obviously the article's a little bit kind of tongue-in-cheek in terms of the realistic nature of this problem. Okay, it would be impossible to get the entire population of the world into one place. Okay, that one place would still be a fairly large area. Okay, because 7.4 billion people. Okay, which is what the Earth's population was a year. Well, in 2016 it was 7.442 billion. Okay, so imagine it's probably a little higher than that now. Right. Getting all those people into one place is a problem, right? Just from a matter of, first off, getting them all there. So that's why it says they're magically transported there. Okay. But secondly, once they're all there, people have certain needs: food, water, sanitation. 7.4 billion people who all have to go to the bathroom all in one place. Pretty nasty. Okay, so things like that are kind of the stuff that would create problems. Okay, so the crowd takes up an area, the space of approximately the size of Rhode Island. Okay, so that's what we'll use as our thing. We actually get everybody to jump, and nothing happens. Okay, the world doesn't end because everyone jumps. The world ends because everybody is in the same place at the same time, and you can't get them all out of there now, because somehow we magically transported them all there, but can't magically transport them all back. Apparently this magic only works one way. Okay. All right, so we've got all these people that have jumped, and now, okay, we're trying to get them all back. Okay, it says 5 billion phones here, something like that. Okay, obviously the cell network in Rhode Island is not designed to handle that many phones. Okay, so it would collapse. Machinery is grinding to a halt. Okay, if people are not around monitoring things like nuclear power plants, for example, they have a tendency to, go their own way, which is generally not good. Okay, so things like that are things that we'd have to worry about. Okay, if we got all the transportation systems in Rhode Island working at the same time, it would take years to evacuate everybody from there. Okay, so essentially Rhode Island would become the graveyard of most of the world's population. If it's like a Walking Dead thing, that's the place you would not want to go. Yes, that's what we're going to say. All right, so the calculations that we have to do here, obviously there's going to be some problems. Just write a couple of problems and kind of, a couple of sentences there for question number 1. Okay, calculate the total mass of the Earth's population, assuming the average mass is 65 kilograms. We are going to say that the Earth's population, just to use a nice round number, is 7 billion. Okay, so we're going to use a population of 7 billion. You will need the Earth's mass. 5.98 times 10 to the 24 kilograms. And of course, the Earth's population would be included in that number, but you don't have to subtract it off when you're doing it. Okay. So we have to do a couple of things here. Determine the total gravitational potential energy of the crowd when they are at the maximum height of their jump, which, as Austin just said, that the maximum height of the jump is 0.5 meters. Okay, we want to find the kinetic energy of the crowd after their fall. Think back to Science 10. Okay, if you jump, you have a certain amount of potential energy. When you come back down, your kinetic energy should be, yeah, should be. The conservation of energy applies. Okay. Law of conservation of energy says that energy cannot be created or destroyed, but the kinetic energy of the Earth will be less than the kinetic energy of the crowd. Explain the difference. Come up with a couple of ideas, okay, as to why not all of the energy from the crowd landing back on the Earth would actually be transferred as kinetic energy to the Earth. Is there other forms of energy that it might turn into? Okay, things like that. They may have mentioned some of them in the article itself. Okay, determine the maximum kinetic energy of the Earth as a result of the crowd hitting it. Okay, so if everything worked perfectly and all the energy went into the Earth, how much energy would the Earth have? Okay, then calculate the maximum speed of the Earth as a result of the crowd hitting it. That's why you need that number right there. Okay, that'll be part of your calculation. And as a result of that, would there be any noticeable effect on the Earth's orbit due to the jumping of Earth's population? Okay, so all things to have a look at, think about, etc. Okay, so I'll give you a little while to work on that. I think you have all the numbers you're going to need now to do that. Okay, and if you want to talk to each other while you work on that, okay, as long as it is on topic, okay, that is fine.